Hello, hello. Thank you for sharing this beautiful day with me. I'm Jim Hatfield of Seagate Technology, and today we're going to talk about a new IEEE standard 2883, the standard for sanitizing storage. Here's a little bit about me. I come from primarily a storage background, but I also bridge the gap between security and storage. Here's a little snippet of what we'll be talking about. What is sanitization, and importantly, what isn't it? What is this standard and why do we need it? What are the methods of sanitization? What can you sanitize? How do you verify and document it? And how can you participate further? Because this is a growing field. So we've defined sanitization as a process or method to render access to target data on storage media infeasible for a given level of effort. So let's unpack that. Target data is data that you want to get rid of. You don't want anybody else to find. Render access to that target data means you don't want anybody to be able to get to it. So that's different than destroying the data itself, because the data is on media, and unless you destroy the media in certain ways, there will be a way to access the data. So you want to be able to make it so that people cannot get the data that you want them not to see. And infeasible for a given level of effort means how hard will they try to get it? If you're involved in organized crime, well, law enforcement might expend a great deal of effort to try and get the data that is associated with you. If you're a nation state, they can exert a lot of effort. If you're just somebody who's got a laptop at home and you want to sell your laptop to somebody else because you want a bigger and better one, well, maybe you can exert less effort to destroy that data, and the person that gets it may not have the ability to exert much effort either. So we've defined 3 sanitization methods in increasing level of effort: clear, purge, and destruct. It is not related to compliance. It is not simply deleting files, because people have been undeleting files for many decades. It's not just unmapping the data and deallocating it. Sure, on an SSD, you can do that and delete your SSD in a matter of seconds, but the data is still there. It's just the file system can't find it. There are a lot of terms in the storage and security industry dealing with elimination of data. These are all very fuzzily used, not used consistently, and there's no clear definition for them. So we've defined a word, sanitize, with a very specific definition. There are ways to destroy or destruct a storage device. Some of them may be effective at making it so that people can't get your data. Others are not so effective. I've spoken with people from data recovery houses, and people have shot a hard drive with a gun Well, they recovered the data because the bullet missed the disks. They've scratched the hard drive surface. They've disassembled it and scratched the platter on top with a screwdriver, not knowing that that was dummy surface and the real data was underneath it. They tell me about people cut floppy disks into many dozens of pieces. With a little bit of effort and Scotch tape, they were able to recover everything. So sanitization is not these things. The scope of sanitization is everything that is user data, was user data, or could be user data. It's also within scope to sanitize information about user data. For example, say you have a 50 terabyte hard drive and an adversary gets hold of it and they want to find out, well, what are the interesting pieces on this? Well, they could go through all 50 terabytes, block by block by block, but if they have a hint that certain areas were used, then that's a clue for them to minimize their effort. So you go look at an error log and you find that, oh, LBAs 4, 5, and 6 were used. That gives a starting point for clues. So sanitization also includes getting rid of information like that. Now, you want to reuse and recycle your devices. You want to reuse a hard drive as many times as you can. A lot of energy and effort went into creating that. There are rare materials and toxic materials that went into that product, hard drives or SSDs, any kind of storage product. And it's good for the environment to reuse that as many times as you can, if you can safely get rid of the data. Similarly, currently, millions of hard drives are shredded each year. And that means you can't get the rare earth elements out of there and reuse those. There are people who disassemble hard drives to get, for example, the special magnets out of there. We want to reuse and recycle as much as we can. So what is this new standard? It's a new international security standard. The I in IEEE stands for international. It's a standalone security standard. It does not depend upon other security standards for its validity and its content. It does, however, rely on storage standards, which it will reference extensively. We define what sanitization is and is not. We define sanitization elements. Here are some things that you need to consider about sanitizing things. We further describe clear, purge, and destruct. And the most important part of this standard is media-specific and interface-specific techniques to implement those clear, purge, and destruct methods. What commands do you use? What process do you use? What is the order in which you have to do some of these things to do it effectively? We also contain guidance about composite devices and that were not considered much in the past. There are so many devices, IoT devices, your doorbell, your electronic doorbell contains data. It contains For example, how to connect to your router. There's data even in your doorbell. It's good to erase those things too. And not all cryptographic erase is the same. You can do it poorly or you can do it well. We tell you what to look for before you use cryptographic erase as a purge technique. Here's a screenshot of the table of contents. And you see Annex B is all about cryptographic erase. So I said that this is a standalone document, but it doesn't stand in a vacuum. Other standards will use it. Now, we didn't, the IEEE did not just create this standard out of whole cloth. It was derived from the ISO IEC 27040 2015 version, which contains guidance for storage security in general. It also contains no requirements, only recommendations. And it contained commands and processes you use to perform sanitization for the devices within its scope. It contains a lot of common text with the NIST document cited here, because they were written at the same time and by many of the same authors. Now, 27040 is being revised right now. We're adding requirements to it. And at the same time that we're adding requirements to it, we're separating the media-specific and interface-specific sanitization techniques to this new IEEE 2883 standard. We talked about this NIST document. It is guidance only. And being a product of the US government, many countries won't refer to it. They want, they want an international standard. The European Union has a lot going on in this area. ETSI Lot 9 on the surface is about saving energy. Well, one of the ways you save energy is by reusing devices and not discarding them. So ETSI Lot 9 has a vested interest in sanitizing storage. And the CENELEC organization in the EU decides which standards from all over the world become European Union standards. It can pick and choose. Just because it's an ISO document doesn't mean necessarily that it's an EU standard. So we're talking with them to reference 2883. Why do we need it? Well, a lot's gone on since 2015. NVM Express has expanded and evolved in many, many ways. SAS and SATA have new features dealing with zoned commands and zone domains and realms. We've got a mutate command that'll let you turn it from one type of hard drive into another type of hard drive. Different kinds of recording techniques have penetrated the market and are continuing to penetrate the market. And recording densities have gotten huge in the since 2015. So we address that as well. And there's a lot of devices that contain embedded storage that you wouldn't necessarily think of, like your multifunction copy scanner fax printer in your office. It has storage in it. And before you sell it to someone or heave it in the trash dump, you may want to sanitize that before you dispose of it. Gaming devices have an amazing amount of storage in them as well. I mentioned IoT, your doorbell, your temperature sensor in your house, your thermostat, your smart speaker. All of those have storage and need to be sanitized before you dispose of them. I mentioned that the demand for green technology has grown immensely. With the discussions of global warming, this has become a priority for many, many governments and private enterprises, not to mention individual people. Again, we want to reuse things as much as we can. Well, before we reuse something, we want to make sure that any data that we are sensitive to is gone before it's reused by somebody else out of our control. I mentioned that the existing 27040 is a guidance document. Well, people want requirements now. Other ISO IEC standards are changing as we speak, due to be published mid-2022. In particular, 27001. A lot of organizations have been certified for this. This is not just storage security. This is IT security. It's physical security. It goes into great depths about everything in your organization. So these two documents, these two standards are changing as we speak, and new certifications will be required by people in the very near future. I mentioned that standards need to keep pace with the industry. The storage industry evolves at an amazing rapid pace, but some standards don't. For example, ISO IEC documents, they want to republish or reaffirm those every 10 years. And they kind of assume that they're fully baked and not much will change. But if you want to change them, it takes 2 or 3 years to publish that. IEEE standards, though, can be revised and published in a year. So I'll show you more in just a moment. And people need demand requirements, and need verification that those requirements have been met. We give guidance on how to identify if you're even able to sanitize it. Say you got a 10-year-old degausser and you want to degauss your hard drive. Well, we give you advice on what equipment you might need. Maybe you need to purchase new equipment. If your equipment isn't working, like your hard drive, it just won't spin up anymore. Well, that's a consideration also. So, in response to all of these needs, the SNIA security twig and the IEEE security and storage work group, we call it SysWig, decided to revise the 27040 and extract the media specific and interface specific information from there into a new IEEE standard, which we can revise on a more rapid basis. Leaving in the revised 27040 the framework of requirements, high-level description of sanitize. How do you choose these? Why do you use one versus the other? It references 2883. And we have a table of requirements so that you can just go down the list and have a checklist. So the revised 27040 and this document go hand in hand. Things that we've added since we have the opportunity when we split things is we've added support for a whole bunch of technologies that were not in 27040 7 years ago. There's a lot of NVMe architectural elements that have been developed and matured, and we cover those. Magnetic tapes have evolved in those 7 years, and composite devices and devices with embedded media are a lot more out there now than they were before. We also take this opportunity to update techniques for how you can destruct things. We have obsoleted shred and pulverize for reasons I'll go into soon. And we give guidance on proper degaussing. We encourage the use of Purge as the happy medium between clear and destruct. And we've consolidated hard drive and SSD techniques because from an interface command level, there's not a lot of difference between an ATA hard drive and an ATA SSD, or the same thing on SCSI or NVMe. And yes, NVMe hard drives are coming. So what do clear, purge, and destruct really mean? Clear means you're using logical techniques like a write command or a format command, using the same host interface as the user would use. It does not address that only addresses the data what is user data. Does not address what used to be or could be user data. Purge addresses the is, was, could be user data, as well as all of the hints, but we leave it in a potentially reusable state. This is our happy medium. This is where we want to be. The destruct method, we don't call it destroy. Destroy is overused and underdefined. So we define a specific term here called destruct, using physical techniques that make recovery of the target data infeasible using state-of-the-art laboratory techniques, and results in the inability to use the storage media for storage. Here you use melt or incinerate, you use degauss with guidance, and shred and pulverize techniques are obsolete now. What do we mean by state-of-the-art laboratory techniques? Well, here's some clues. Here's some hints as to what some of the things are. Now, data recovery houses have a lot of trade secrets for how they do things. And of course, nation states have even more techniques that they don't tell about. So you got clear, purge, and destruct. Okay, that's all fine and dandy. How do you choose which one to use? Well, start with the guidance and the requirements in the ISO 27040. Your organization may have its own policies. If you're a large data center, your organization may have a policy that nothing is allowed to leave the data center in a usable state. So maybe destruct is what you want. Maybe you're a local business, or an individual. And your local policy is, well, I'll do the least I can and hope for the best. So after you've chosen, and establishing what the risk of finding the information by somebody else is, that's very important. If you're storing your taxes on your hard drive, that's one thing. If you're storing illegal materials on it, that's another thing. That those risks are very different. You have to locate all copies of your data too, because this applies especially in the cloud. You may have backups, you may have temporary copies of things. Just because you have a file system in your operating system, I know for a fact that not all data that the operating system uses is in the file system. So just because you delete all the files doesn't mean that all of the data that the operating system keeps is destroyed. There's a lot of things that are not inside the file system. So here's our basic process. Say you start with clear. The rectangle that says clear includes the clear method and the clear technique and the verification. If the clear and the verification were successful, you document it and you're done. Or say you had a power failure in the middle of it. It takes 20 hours to do your overwrite here. And you get a power failure in the middle. Okay, you can start your sanitize and start over and do the clear. Keep doing that until it succeeds without a power fail. At some point though, you might say, well, clear didn't work, but I'm not okay with handing it off to somebody unknown. Well, now you fall down to purge. You do the same thing. You purge, you verify. If it was successful, great, you're happy, you go home and you're done. If the purge method doesn't work, for example, your hard drive doesn't spin up or your SSD has a crack in it or something, then you go down, then you fall through to destruct. Here's some examples of some sanitization techniques for clear, purge, and destruct. I mentioned that overwriting a large capacity device may take days, hours, or weeks to do. If you've got 50 petabytes, it's going to take more than a few minutes to sanitize all that data. A crypto erase, on the other hand, can happen in mere seconds. And of course, we talked about how destruct creates e-waste. We give a guidance on, again, how to choose what kind of technique to use. Overwrite has different meanings. We do not mean simple overwriting here. Simple overwrite can be used for clear method, but not for purge. The sanitize overwrite command is acceptable for purge, and overwrite is not acceptable for non-magnetic media in the first place. It's just not effective. For SSDs, the hardware down at a deep level has blocks, and there's a thing, a primitive function called block erase. You use block erase using the sanitize block erase command, and you'll be good. Cryptographic erase, again, there are preconditions for using it. You have to know that the provider of the cryptographic erase mechanism did it the right way. We have guidance in there for how to tell that. Destruct, we've talked about melting and incinerating. Here are our definitions for those, but both of these generate e-waste. Shredding and pulverizing are not acceptable anymore given the increased amount of density of data. For example, here, in this example, a square inch of a hard drive, just one surface, be about 1.3 terabytes of bits. Now, if there are 2,000 bytes on a page of paper, then that 1 square inch can contain the equivalent of 8 million pages of data. So even if you shatter your hard drive into little pieces, there could be enormous amounts of data recoverable from there. The NSA shred limit is 2 millimeters squared, but that's still an enormous amount of paper sheet equivalents. Degaussing has its own problems. If you have a degausser that worked fine 10 years ago, it won't work with the data densities that we have today. So we give guidance on that. In addition, some tape devices have servo tracks on them. And so while you might be able to degauss audio tape or videotape, degaussing LTO tape will render those unusable. And just because you degauss a hard drive might mean you've just impaired the motors or the head mechanisms, which are magnetic, but you may not have degaussed the data. So proceed with caution. Here's some things that we cover about sanitizing. An SSHD is a solid state hard drive. It has magnetic and non-magnetic media in it. We've extended our coverage of hard copy to include other things that you might find in a printer. These types of media we carry over from 27040. We cover mobile devices and composite devices more. I'll mention that network hubs, routers, and switches, they have information about your firewall. So if you're law enforcement and you grab somebody's router, you can find some interesting information about what websites they've been going to and which websites they've been blocking. Commercial printers, they have storage in them too. We've all heard horror stories about a commercial copy center that sold a copy machine when they were done with it, and the hard drive inside it contained scanned images of taxes and all kinds of other interesting things. We cover a whole bunch of host interfaces. Short talk about verification. Just because the device said it sanitized, it doesn't mean it really did. If you might have a hard drive with a write head that acts as if it's writing, but didn't actually write, or didn't write with sufficient strength to overwrite what was previously there. You might have firmware that has bugs in it so that it thought it sanitized the data, but it didn't. Or you might have devices that intentionally pretend to sanitize and don't. Trust but verify. 27040 has information about how you document the sanitization results. 28883 has guidance for how you can gather information for that process. And standards are never done because technology doesn't stand still. DNA storage is coming. Cloud storage is here. There are many copies of data in the cloud. To sanitize cloud storage, you have to go after all of them. Well, those might be in many, many places with backups. We do not cover that right now. Another up and coming technology is encrypted storage, hard drives and SSDs, where the keys are managed outside the storage device. In a normal self-encrypting drive today, the media encryption keys are in the device, never leave the device. They're not visible to the host. The host has no clue about them. But the industry is developing devices where those media encryption keys are injected into the device. And think of all of the storage and data flowing in a self-driving car. It's enormous amounts of data. Well, some of that is stored, some of it is not. So before you sell your car to somebody, you might want to really cleanse that car, not just on the surface, but cleanse the storage inside it. We don't know how to do that. If any of you are subject matter experts in these areas, we would love for you to participate with us. So join the SNIA security twig or the IEEE security and storage work group. We call it SysWig. The Insights Cybersecurity and Privacy Technical Committee, they are the US gateway to ISO standards. So if you want to participate in ISO standards development, join that group. Then here are some websites where you can get the actual standards and more standards. So security standards and storage standards. And thank you very much for your time. Hope you join us to discuss this further and develop these wonderful things. If not, get a copy of the standard and dig deep and find what we've been up to. And we think that you will enjoy using our new standard. So thank you very much.